In this session, we'll examine the fundamentals of how we interact with the AutoCAD program through various menus, icons, and mouse techniques. We'll begin at the startup screen that is shown here. The largest window which is now visible is the graphics window. This is where we'll draw and modify our parts. Notice as the crosshairs are moved within this window that the numerical values displayed in the lower left corner of the screen change. These values are the X, Y, and Z coordinates of the crosshair. The lower left corner of the graphics window corresponds to the origin of the coordinate system. Along the top of the screen are the pull-down menus. After moving the cursor over the desired option, we'll click the left mouse button to highlight the option and display the list of available pull-down commands. Using pull-down menus is not the only technique through which commands are given to AutoCAD. We can also select commands by clicking on icons that are contained as part of a toolbar. Notice that as we move the cursor over the top icon on the drawing toolbar, we see the command line, which can be given by clicking on this icon. There are two other toolbars that are currently displayed on the screen. The standard toolbar is displayed horizontally, directly below the pull-down menu options. It contains frequently used functions such as the undo option shown here. The other toolbar that is available on the screen as it is shown here is the modify toolbar. It contains the erase icon as well as other icons that will allow us to make changes to our drawings. Later in these lessons, we will learn how to customize the interface and add additional toolbars to our screen. AutoCAD also allows commands to be typed in from the keyboard. When this is done, your typing shows up in the lower portion of the screen called the Command Prompt area. AutoCAD also uses this region of the screen to display prompts, so we'll need to keep an eye on this area of the screen. At the very bottom of the screen, just to the right of the coordinates, is the status bar area. It contains buttons starting with Snap and Grid. As we left-click on these buttons, they toggle between an on-off status. We will find these buttons allow us quick access to various drawing aids available in AutoCAD. AutoCAD makes use of both the left and right buttons on the mouse. The left button is used to select menu options and icons as well as to indicate locations within the graphics window with the crosshair. As we will see, the right mouse button is used to accept default options of a command or to end a current process. We will find that the escape key is useful in canceling a command that we entered by mistake. If you find yourself in the middle of an option that you entered by mistake, you can usually exit the command by pressing the escape key once or twice. In this session, we'll illustrate how figures which are composed of a collection of lines can be created. In order to give AutoCAD the command to draw lines, we'll move the cursor over the line icon button and then click the left mouse button. We'll now move the crosshairs to the location on the screen where we wish to start our first line, and then again left-click. As you can see, a line is displayed as we move the crosshairs away from the location where we just clicked the mouse. We'll define the other endpoint of the line by again left-clicking the mouse. We'll now continue to draw lines which form the shape of a five-pointed star by left-clicking at the end of each line. In order to stop the process of drawing lines, we'll now click the right mouse button. This causes the pop-up menu shown here to be displayed. We'll now select the Enter option from this menu by left-clicking on it. The star that we have just created was done in a manner similar to freehand sketching. The vertices of the star were not defined to have any specific coordinates. However, since exact coordinate locations are very important in drafting, AutoCAD provides a number of ways in which to define these. We'll examine one of these techniques by first selecting the Grid option in the status bar. Notice the grid pattern of dots that are now displayed in the graphics window. The AutoCAD default spacing of the grid is 0.5 units. We'll now turn off the dynamic input and then select the Snap option. This causes the crosshairs to snap to the closest grid point. We'll now use this combination of grid and snap options to draw another 5-point star after we click on the line icon. Notice that as we now move the crosshairs, they snap to the grid points. The corresponding coordinate locations of these grid points are displayed in the lower left corner of the screen. We therefore know the exact location of the vertices as we sketch our figure. Before we create any more figures, let's now take a look at how we can remove part or all of our drawing. We'll start by clicking on the Erase icon in the Modify toolbar. We'll also click the Snap option to turn it off. This will make it easier to position the selection cursor, which appears as a small square. We'll now locate the cursor over several of the lines, left-clicking on each one to select them. Notice that the lines turn into dashed lines as we click on them. We'll now click the right mouse button. The process of right-clicking tells AutoCAD that we want to accept the selected lines and erase them. Another technique that can be used to erase lines is to first select the lines and then give AutoCAD the Erase command. We'll illustrate this by moving the cursor above and to the left of the remaining lines, and then clicking the left mouse button. Now we'll move the cursor to the opposite corner so that all the lines are enclosed within the rectangle, and then left-click again. Notice that all of the lines are selected. We will now right-click, which displays the pop-up menu shown here. And finally, we'll select the Erase option on this menu to remove the selected lines.
Okay, go for it.
In this session, we'll construct a drawing of the guide plate shown here. During this process, we'll make use of several different techniques to define the different locations on the guide plate. We'll start the process of creating lines by clicking on the line icon located in the drawing toolbar. In order to define the starting point of the first line, we'll key in the coordinates 0, 0, and then press the Enter key. Notice that as we key in values, they are displayed in the command prompt area. Our first line will represent the bottom of the guide plate, which is 5.5 units long, so we'll key in 5.5, 0 to define the other end of this line. The line that has just been created is located along the very bottom edge of the graphics window. In order to improve the display, we'll move this line upward. We'll first click on the pan icon. And now we'll position the cursor in the middle of the drawing window, and then click and hold down the left mouse button while we drag the cursor. After we have positioned the line at its current location, we'll let up on the left mouse button and then press the Escape key to exit the pan option. We'll now create a vertical line that is 2.5 units long by using the Relative Rectangular Coordinates Entry method. This is done by keying in an @ sign followed by the coordinates 0, 2.5. We'll now turn on the grid and snap options by clicking on their option buttons. Since the next line has endpoint coordinates x equals 8, y equals 2.5, we'll move the crosshairs over the grid to this location and then click the left mouse button. We'll now use the Relative Polar Coordinates Entry method in order to define a vertical line that is 3 units long. This is done by typing @3 followed by the less than sign and then the value 90. For the diagonal line, we'll type in the relative coordinate entry @-1.5, 1. For the top horizontal line, we'll use the direct distance entry. We'll do this by positioning the crosshairs directly to the left of the end of the diagonal line that we just drew. Now we type in 6.5 followed by the Enter key. In order to finish the outline of our figure, we'll click the right mouse button followed by clicking on the Close option. We'll now create the first circle on the guide plate by selecting the pull-down options, Draw, Circle, Center, Diameter. Notice the prompt indicates that we need to specify the center of the circle. We'll do this by keying in the coordinates 3, 3. We'll now key in the diameter of 2.5. In order to draw a second circle, we'll right-click the mouse and then select the Repeat option from the pop-up menu. We'll now use the Relative Coordinate Entry method to define the center of the next circle, so we'll key in @2.5, 2. and then we'll key in 1.5 for the diameter of the circle.